Hello boys and girls, and welcome to Lesson 1, Unit 1, Chapter 1, first lesson. Okay, the first lesson of the year. We're going to be looking at ratios and rates. Now, for some of you that are not used to watching my math videos at home, what I'd like to do is kind of summarize what we've looked at in class and help you with some of the questions that may have been difficult or challenging for you in class, and in addition answer some other questions that require writing or more complex vocabulary. So take these videos as your own personal tutor at home. Okay, take advantage of them. And yes, they are mandatory. You must watch them all. You must watch them right through. So the best way to do it is just open up your homework and play this video as you're doing your homework. Remember to pause to answer the questions that I do not answer during the video. Okay, so as I said, Chapter 1, ratios and rates. What are they? Well, a ratio looks like a fraction. Okay, it looks like a fraction, but it's not. Okay, it can actually be part of what we call a complex fraction, but we'll get to that a little later. And a rate is often two variables being compared. Okay, for example, I have a rate right here with apples and oranges. Let's look at that. Okay, if I look at this, apples and oranges, we have rates. Okay, and here we have the ratio of apples to oranges is 3 to 6, meaning that for every time I have 3 apples, I'm going to have 6 oranges. So it would look something like this. 3 apples means I have 6 oranges. Okay? That looks like a fraction, but it's a ratio, right? It's a ratio that we're talking for every 3 of these, I will have 6 of those. And that's how it's written. Now, it can go up or it could go down. You can double. If you double the top, you must double the bottom. So now let's say if I only have, for example, 1 apple, how many oranges will I have? Well, 2. Okay? You see how it's simplified? 3, I have 6. 2 apples, I have 4 oranges. 1 apple, I'll only have 2 oranges. Okay? So what I did there was I brought it down to a unit. So a unit would be 1 and 3. That means that for every apple there are 2 oranges. So the simplest form of this ratio is 1 for 2. There's 1 for every 2. You see that? 1 for every 2. We don't say a half because it's not a fraction, it's a ratio. So for every 1 we have 2. For every 3 I have 6. For every 2 I would have, you saw it already, for 2 we have 4. Okay? And for every 1 I have 2. You can also double it. For every 6 I would have, for every 6 apple I would have, if you said 12 oranges, you are correct. So that is a ratio. Now as you can see, the image that we use for the beginning of the chapter is it's a cheetah. Why a cheetah? Well, take a look at this interesting fact right here. Cheetahs are the fastest land animals. They say land because I think for water, I think the dolphins is the fastest, the dolphin. Or actually no, the swordfish, maybe. They can chase prey by running at speeds of 60 miles per hour. 60 miles per hour. That is a ratio. They can go 60 miles in 1 hour. You see, we're comparing two variables. We're comparing distance and time. So there's the 60 would go on the top and the hour would go on the bottom. Okay, a cheetah can only maintain top speed for a short amount of time. They can't do the whole hour at 60 miles. No way. No, at 60 miles an hour. That's too fast for too long. If a cheetah runs 1 mile in 60 seconds, fill in the diagram to show how far the cheetah would run in 210 seconds. Well, 1 mile in 60 seconds. 2 miles in how many seconds? 120, right? 2 minutes. 3 miles in how many seconds? 180. And then from 180 to 210, we only have 30 seconds, which would only be half a mile, right? Because it's half, so you got to half the other variable. So, how far could it run? If you're thinking 3.5 miles in 210 seconds, you are correct. That is a ratio, boys and girls, and that's what we're going to be working on in class. I hope you're getting this. Okay, let's go ahead and turn the page to fill in the definitions for this chapter. Okay, so now let's work on page 7. On page 7, we have to identify what the greatest common factor is and what the least common multiple is. This is something that typically people tend to confuse, but here is a little way that you can try to memorize it. Okay. Greatest common factor. We're looking for factors. Factors are numbers you multiply with one another. You multiply them to get a product. Or in this case, we could also call it a multiple for the sake of definition. But you must multiply factors to get a product, to get the multiples that we're going to count by. And then when we talk about the least common multiple, we're talking about numbers that will be in common when you count by a certain number. Like, let me give you an example. For example, if I count by tens, 10, 20, 30, 40, and I count by 12s, 12, 24, 36, 48, eventually there's going to be a number that is in common between the two of them. Okay? To me, the first one that springs up, which is the least one, the first one to come in line as I'm counting, is 120. So that's the least common multiple for those two numbers. Okay? But the greatest common factor, when I am multiplying two numbers to see if I can get, so I can multiply 2 times 5, I get 10, or I can multiply 2 times 6, and I get 12. 2 is the greatest common factor. It's the factor that you can multiply for the two numbers. Okay? But here I've drawn up an example. So take a look. I have number 56, okay, and number 42. These are multiples. If I were to count by 56, I get 56, 112, and 168. Right? If I'm counting by that. If I'm counting by 42, I'm counting 42, 84, 126, and 168. You see that? So I got 168 as my least common multiple. But now let's find the greatest common factor. If I'm multiplying, I need two factors that I can multiply 56 into. Okay, so I'm going to take, for example, I could do 7 times 8. Or I can do 4. Let's just take that 8 and I divide it into 2, right? 7 times 8. Then I can have double the 7. So this is kind of like multiplying, for some of you that are a little more advanced, this is like multiplying 8 times 7. Except I half this, the 8 to 4, and I double the 7. So I get 4 times 14. And if I do the same thing with 42, 42 is 6 times 7, right? Or I can half the 6 and double the 7. I would have, if I half the 6, I get 3, double the 7, I get 14 as well. Look at that. My greatest common factor is 14. Okay? Alright, so now let's take a look. The common factor is a number that is a factor of 2 or more numbers. The greatest of the common factors are 2 or more numbers is called the greatest common factor. The least non-zero number that is multiple of 2 or more whole numbers is the least common multiple. Alright, that's a little bit of a hard sentence to understand because it's very technical. So let's break it up. What's the greatest common factor? What's the least common multiple? Okay, so let's fill these out. So as you already know, this entire page will be a key answer. So please make sure that you mark it by putting a star there and maybe a nice little smiley face right there. Okay? So that when I check your work, I know that you watched this section of the video. So, greatest common factor, GCF. What does it stand for? GCF. There it is. Greatest common factor. Okay, there it is. Now define it. What do we mean by greatest? The largest of a set of values. Well, what does common mean? Common means the same. What do two things have in common? Well, what do they have that's the same? It's what we mean. So here it means the same feature among several numbers. So the same value, the same number. Okay, so the largest, the biggest same, the largest same. And what does factor mean? Well, we know that factors are numbers that are multiplied into one another, so we can just simply write a factor is a number that is multiplied by another number. Okay, so always when we're looking for the greatest common factor, remember the word factor, we're looking for numbers that multiply into one another, and we're looking for the biggest one, the greatest one. All right, look now at lowest common multiple. As I mentioned, you count by a number, by a certain set of numbers, 10, 12, or we could do by 6, 12, 18, 24, and then we try to see which common factor it would have with 8, 16, 24. Oh, 24 is the common between 6 and 8. So what does LCM stand for? There it is, boys and girls. Go ahead and write it in. Least common multiple. Well, what do we mean by the least? If you're thinking the smallest, or the smallest value, you are correct. Go ahead and let's write that. Okay, so the smallest of a set of values. What does common mean? Common is the same as when we talked about the greatest common factor. It is the same feature among several numbers. Okay, so common, what is the same? And multiple. What does multiple mean? Well, the multiple, as I mentioned, is the product of two factors. Okay, it's the product. So the product of a number and any whole number. So it's not just the product, it could be any whole number that you're deciding to count by, as we've done. Okay, go ahead and write all these down. Make sure you have them exactly the same way. I will be checking for these. Now, how can we make a real world link to this? Take a look at the bottom. Okay, at the bottom, we have Brian is making a balloon arrangement. Okay, it's making balloon arrangement. He has 8 blue and 12 green balloons. What is the greatest amount of arrangements he can make if he wants them to be identical? And this is where we get ratios, boys and girls. This is where we get to use ratios, 8 balloons to green balloons, and we're looking for the greatest amount of arrangements. Okay, the greatest amount of arrangements. So what do you think we're looking for? Are we looking for the greatest common multiple, or are we looking for the greatest common factor? If you thought of factor, you are correct. The most you can make would be, what is the greatest common factor between 8 and 12? If you're thinking 4, 4 is correct. So you would want to write 4 arrangements right here at the bottom. 4 arrangements.